Hi, I'm Nick, and this is my final project for Duke University's Human Factors in AI course, the third and final course in the AI product management specialization. This builds on my work in the previous course, where I designed a machine learning powered waitlist for a healthcare marketplace. This time around, I'll be focusing on human factors, UX design, data privacy, and ethical considerations. Ready? Let's go. Patients often want to book a specific provider, but if no near-term availability exists, they're stuck checking back manually over and over. This is frustrating, inefficient, and leads to drop-offs. Patients may either give up or book elsewhere. My solution? A machine learning powered waitlist that predicts availability openings and notifies patients when a slot becomes available. It's helpful to perform a task analysis of the current user flow early in the design process to identify opportunities. This breaks down what users are currently doing to reach their objective into a series of key triggers, actions, and decisions. These are all places where technology can help augment or automate user effort. We can see there are some key opportunities where we can help out the user. First, helping them decide whether it's worth waiting for a new availability to open up. And second, automating the task of checking for availability. We can use an ML solution to augment the user's decision process and also use it to completely automate the process of checking for a new availability. Now let's talk about the user experience. My solution presents a waitlist component and CTA where we show provider availability, such as on the provider's profile page. If there's currently no availability in the next 2 weeks, and our model predicts that at least one slot will open up, we'll present the waitlist to users. We'll show the waitlist until the waitlist is filled up. The depth of the waitlist depends on how many slots we predict will open up. If a user joins the list, they'll receive notifications when new availability arises. The system will stagger the notifications using a heuristic to avoid triggering a mad rush for a single slot, which could lead to user disappointment. Users can click the info button to learn more about the waitlist and its predictions for this provider's availability. We'll ensure that we're building transparency into the product so that users will trust it. We'll explain what data the model uses for predictions so that users have an intuitive understanding of how it works. We'll also communicate the uncertainty of our predictions to help them make decisions more confidently. For example, we'll provide the likelihood of new availability and use friendly labels to give a prediction of how much advance notice there will likely be and how frequently slots become available. We'll also make sure that users have agency throughout the experience. They can remove themselves from watch lists at any time, and they can use an entirely new page to view and manage their watch list subscriptions. Finally, we'll make sure to collect feedback from users at key moments in the flow to improve accuracy and usability. The model can also use user interaction data like clicks and bookings to refine itself and optimize performance of the feature and user engagement. Since this involves healthcare bookings, privacy laws are particularly important. Under HIPAA, patient waitlist data would be protected health information, or PHI, because the marketplace operates as a business associate of healthcare providers. During sign-up, users would have had to have provided opt-in consent for us to use their PHI in accordance with HIPAA, and we also would need to ensure that they read and agreed to our privacy policy. CCPA compliance ensures patients can request a record of their waitlist history through existing flows. To minimize risk, we'd also limit data exposure. For example, notifications would only include the provider's name and not visit details. Now let's turn to how we might mitigate the risk of bias in the system. Representation bias, learning bias, and feedback bias are all examples of biases that might find their way into our solution. These could result in the waitlist feature being less often available for people in certain demographic groups, like certain ethnicities, elderly, or low-income patients. We'd employ various mitigation strategies at all steps of the product development cycle, which you can see here. How do we ensure that we're implementing an AI system that is ethical? Well, there are three main considerations: fairness, accountability, and transparency. In terms of fairness, we'll make sure to test for individual and group fairness during model training, including during data collection. We'll employ developers and stakeholders from underrepresented groups and make sure that we beta test with them as well. And we'll monitor model performance and other metrics across demographic groups to ensure that it's working for everyone. We also need to ensure accountability, which is why we'll provide recourse for users to contact us and resolve issues, and employ regular processes for auditing and analyzing user feedback. And we'll build transparency into the user experience, as we talked about earlier. In summary, this ML-powered waitlist enhances the patient experience by removing guesswork and frustration. improves the provider scheduling efficiency, and ensures a fair, privacy-compliant implementation. By focusing on UX, fairness, and privacy, we've built a feature that is intuitive, ethical, and impactful. Thanks so much for watching. I really appreciate it. Have a great rest of your day, and I'll see you soon.